Hello YouTube. If you remember from last week, this amplifier that I showed you, the biasing and how it affects the output signal. Well, we took it a couple notches up. As I said, this week we were going to build a RF amplifier. So I'll show you how the build looks now. As you can see, it got a lot more complicated. But there was the same amp circuit I used last week, but now I have some additional parts on here. I have a radio frequency tuned circuit, a low pass filter, and over here we have a homemade RF detector to demodulate the RF and turn it back into audio again, so you'll be able to hear the radio guy. So let me turn this stuff on and you can see how it works. Now on the scope here, that's the RF wave that the amplifier is amplifying, of course, just from me holding the antenna. And if we turn on the sound, we can actually hear what's going on there.
Build a Christian community that's devoid of mission is going to ultimately lack purpose and
got a little bit of a hum in there.
Because you're missing.
It's kind of hard to get rid of with these new these new LED lights. So
I don't know.
As you can see, I adjust the tuning capacitor. You can see how it goes up and down because it's putting a coil at resonance to
when they're created just for the sake of
just pick up the signal.
And it always ends up dissatisfactory.
Now over here, we'll let you take a look at the circuit itself. And it's quite the jumbled mess of wire, let me tell you. But yeah, it's a simple radio. I said over here is the tuned circuit, over here is the amplifier, and over here is the RF detector. Now how the detector works is it just rectifies the RF energy. The bypass capacitor you need, so you're not feeding any voltage into these diodes. The one phase is shorted out with this one diode, the other phase is rectified into DC. That's how the RF detector works. And like I said, the tuned circuit, I don't want to really get into it, but it's you know, a resonance between a variable capacitor and a coil. And then this is just a low pass filter. In audio circuits, you could use a resistor here, but in RF, you'd want a coil because the RF will easily go through the capacitors and it'll have a hard time going through the coil. So yeah, that's just a low pass or a high pass filter. And just to show you one more thing on the scope, when I go back to it here, let me switch the scope to DC. Right now, I have it in AC mode. And wow, where'd my wave go? Yo, what happened here? Wow, it's way up there. Oh, I know why. That's because I'm on the output of the transistor. Let me go to the detector. Yeah, I was on the output of the transistor. That's why it shot up in the air like that. Let me go down here and get the wave again. Now, as you can see, as the volume of the wave increases, so does the DC voltage output from the RF detector. But that's normal. Yeah, as your signal increases, your DC also increases from the detector. That's probably why on some of these really good radios, you'll notice how they have that meter that shows signal strength. Well, this is basically how they derive a signal from the detector to operate that meter, you know, to show you your signal strength. Yeah, that's basically an RF amp, but it's actually a simple radio too. I believe this radio is called a tuned RF receiver. Unfortunately, I don't have many more stations around me that you can hear. I'll turn the audio amp back on. And I got a lot of hum too because of these LED lights in my house. If I shut them off, it would get a lot quieter, but then you won't see anything. But yeah, that's it for this week. I hope you enjoyed it. You guys take care. See you again.